Okay, so we can start now, everybody. So good afternoon, everybody. So as I said before, every processor has a number of registers. Okay, so for our microcontroller, we have these registers. We have as you see here, every register is 32 bits. This is the size of the register. By the way, if it is 32 bits, okay, so if you want to write in hexadecimal, so how many digits we need? We need 8 digits. You got what I'm saying? Because every digit in hexadecimal is 4 bits. Okay, so 32 bits, the minimum value I can store in 32 bits is 8 zeros. Is that right? Hexadecimal until 8 F's hexadecimal. Is that okay? Because every digit is 4 bits. Okay. So as you see here, and so here you can see we have starting from R0 here, from R0 until R12, we call it general purpose. General purpose means you can use it in your programs, and that's what we are going to do. Okay, if you want to do addition, subtraction, you can use these ones. Okay. Remember, as I told you before, what is registers? Okay, register is a storage unit, so it's a unit to store data, to store 32 bits. Is that okay? I can also use memory to store data. Is that okay? And that's what we're going to do. Some of your data here means like variable, arrays, and so on. Maybe if you have a variable X, you can decide variable X, I'm going to store this variable in one of these registers, for example, R naught. So R naught represent your variable X. X can be speed, can be whatever X is. You got what I'm saying? Or your variable can be a memory location. Okay, but in this case, listen to me. I made it clear, and that's what you are going to see tomorrow. Every location in memory is storing only 1 byte. Is that okay? So that means if your data, if your variable is 32 bits, so it has to take 4 locations in memory. Is that okay? As you will see, as I'm going to explain later also in details. Okay, but that's what you should understand. So if your variable is a word here means 32 bits, that means it's going to take 4 locations in memory. Okay. But again, it's going to be stored in 4 locations, but that doesn't mean it is 4 different numbers. No, it's not 4 different numbers. It's just 1 number. That is why. So, but this number is going to be stored in 4 locations. That's why if you want to read this number, always I'm going to read the 4 location. If I want to write to the variable, I'm going to write to the 4 location. It doesn't make sense to read only 1 byte. It doesn't make sense. You understand what I'm saying? So don't be confused. Yes, it is 1 number, but this number, I'm going to break it down because every location in memory store only 1 byte. But logically, yes, physically, this number is stored in 4 location, but logically, it doesn't mean these numbers are 4 different numbers. No, okay? This is just a part of the 32 bits, okay? Anyway, so I'm going to give you details on this later. So for now, so we have here general purpose registers. This general purpose register we have until R0 until R7. These are low, we call them low register, and these ones are high registers. Why you call it this way? Because as I'm going to explain later, some instruction can only work on low registers, okay? But all of these are general purpose. Again, general purpose means you can use it, right, in your program, and that's what we're going to do tomorrow. That's what we're going to do all the time, okay? And then we have other registers, we call them special purpose, okay? Again, you can tell from the English name what special purpose means. That means you cannot use them to store your data or to do, so they have a special functionality. For example, PC, I think I talked too much about PC. So PC is used in order to keep track of the instructions in the memory. And also that's what you should see in tomorrow's lab. In tomorrow's lab, you are going to see, after you execute every instruction, you will see how PC is updated. PC is updated, okay? And I made it clear last time. PC is a pointer, and pointer because PC is not storing data, it's storing address of the data because the data itself is stored in memory. Is that okay? That's what you will see tomorrow. So what you will see tomorrow, PC is stored, is pointing. That's why we say pointing. What do you mean by pointing? Pointing means it's storing address. Is that okay? So storing address for the data. Okay, but the data itself, it is in the memory. Okay, that's what you are going to see tomorrow as well. Also, we have other register. We are going to talk about them later. So I don't want to talk about them now until when the time comes. Like for example, stack pointer. This one is used only for stack. So I'm going to talk about later for sure. But for today, I'm going to complete what I started last time. I started last time to talk about this register, PSR, program status register. Okay. And sometimes, yeah, PSR. And sometimes we call it flag flag register. Why? Because this register has the flags, okay? And also that's what you are going to see tomorrow. So what do you mean by flag? I'm going to tell you what I mean by. So this register, every bit is independent, and every bit is flag. What do you mean by independent? I mean, if you change this bit, it's not going to have impact on the other bit, okay? Because every bit is independent. Anyway, so for now, I'm going to teach four flags, okay? Every flag, very simple. Every flag, just one bit. That's true. So we have here, we are going to talk about one bit. We call it a flag. Every bit, very simple, can be 0 or 1. That's it. Okay. Also, these flags are updated automatically after you execute every instruction. Okay. So after you execute the instruction, these flags, the hardware is going to update them. Okay. Everything I'm teaching now is hardware, right? So even these flags are hardware. So they are updated automatically when you execute every instruction. And this flag, every flag is going to tell you something, okay? And we are going to use them. How we can use them? Last time I explained, or let me finish. Let me first go through them here. For example, we have, as I said last time, we have the 0 flag. So 0 flag, this bit either 0 or 1. Is that okay? So if this flag is 1, that means the result of the operation I did, because these flags are updated automatically after you execute every instruction or after you execute every operation. So that means the result of the instruction you executed is 0, right? So I did subtraction, I did whatever, and then the result was 0. If the result is 0, the 0 flag is going to tell you the result is 0. Is that okay? We have another one. We'll call it, but before I move to the other one, so how this can be useful? By the way, sometimes we call it the equal flag, 0 flag, or sometimes we call it equal flag. Why? Because this flag can be used, and the other flags, by the way, can be used for comparison. If you want to do by hardware, if you want to do something like that, as we did in C language, if A is equal to B, if I want to do something like that, similar to what, how the hardware can do some condition like this one. Actually, as you will see later in this course, in order to do something like that by the hardware, the way we do it, we write 2 instructions, not 1, 2 instructions, okay? The first instruction is actually subtraction. So you are going to subtract. This is one instruction. And then this instruction, after doing subtraction, this instruction is going to update the 0 flag automatically. So after doing subtraction, if the result is 0, in other words, A is equal to B. If A is equal to B, the result is 0. And because the result of 0, the flag is 1. So the 0 flag should be 1. Is that okay? And then right after this instruction, I'm going to use jump instruction. But conditional jump. I'm going to say, if the 0 flag is 1, we have this instruction. If 0 flag is 1, please jump. That's how, okay? That's how we can build a condition like this one, okay? So one instruction to set the flags. The second one is going to use the flags to decide either to jump or not. Okay. Anyway, I'm going to give you details later. All what I need you to understand today. And number one, what flags? Okay, you understand what I mean by flag. I already explained the 0 flag. Also, you should understand the updated automatically after executing every instruction. By the way, some instructions don't update the flags. So some instruction do, some instruction don't. Okay. Anyway, but I'm talking about now if instruction updates the flags. So here, this 0 flag is going to tell you if the result is 0, so the hardware is going to make it 1. If the result is not 0, and already I explained how can we use it. Is that okay? Same thing. Another flag. The other flag is the negative flag. N flag. Okay. Again, you can also tell from the English name if you do a certain operation and if the result is negative. As I said, as I explained before, if you have a number, right, and this number is negative, what it means? It means the most significant bit is 1. Okay, guys, please don't be confused in this point. Listen to me. If your number is a byte, so when I say the most significant bit, I mean bit number 7. But if your number is half word, which means 16, so when I say the most significant bit, it means it's number 15, and so on. What I'm saying? So everything I'm explaining right now, maybe I give you small example, but because I don't want to write 32 bits, okay, I give you small example on 4 bits or 8 bits, okay, but still it's general, okay, it can be used for any size of bits. You understand what I'm saying? Anyway, so what I'm saying here is, if the result, if you did operation and there was a result of this operation, if the result is negative, that means the negative flag is 1. If the result is not negative, it means a positive or 0. Anything else other than negative, it should be 0. By the way, if the number is negative, this one is 1. If the number is positive, is not negative, this bit is 0. So you can see they are aligned. They are the same. You get what I'm saying? They are the same. So if this number is negative, the most significant bit is 1, and the N should be 1. If this number is not negative, so the most significant bit should be 0, and this one should be 0, right? So I can say easily what's going to happen. I'm going to copy the most significant bit, put it in N. So N should equal the most significant bit. Yes.
Does the N flag still come out of 0 to 1 even if it's unsigned?
That's a very good question. I was about to raise this question. Thanks for this question. Okay, guys. This is a very confusing part of what I'm explaining right now. I said it 2 times. I'm going to keep repeating it until you understand it. Processor hardware does not know if the numbers are signed or unsigned. That is why it's going to give you the 2 solutions, and this is something you have to consider in your program. You got what I'm saying? So what I mean, maybe this is my number, maybe it's unsigned. Okay, my processor doesn't know. So what the processor is going to do, even if it is unsigned, and it's going to consider this number signed, if it is unsigned, right? And it's going to give you the negative flag. You got what I'm saying? And in your code, because your number is unsigned, you may not need it. You may not need the negative flag. You understand what I'm saying? So if processor doesn't know if it is signed or unsigned, so when the processor calculates the negative flag, it's going to assume this number is signed, even if it is not. And then it's up to you in your code to use it or not. Same thing, like what I'm going to explain right now. Same thing for two other flags. Carry flag and the V flag. The carry flag should tell me if there is unsigned overflow or not. The V flag should tell me if there is signed overflow or not. Again, the processor does not know if your number is signed or unsigned, but it's going to give you the 2 answers. You got what I'm saying? It's going to give you the 2 answers. So if your numbers are unsigned, so when it calculates the carry flag, it's going to assume the numbers are unsigned. When it calculates the V flag, it's going to assume the numbers is signed. And now it's up to you as a programmer in your program. You want to know if there is overflow or not. So all what you are going to do, if your numbers are signed, so you have to look at this one. If your numbers are unsigned, so you have to look at this one. I know this confusing. I remember because that's what I'm going to do tomorrow in the quiz. And that's what I'm going to give you a lot of examples here. So what I'm going to do in the quiz tomorrow, I'm going to give you something like that. And then I'm going to ask you to give me what are the values of the flags. Okay. One time, or it happened really several times, some students, when I ask them this question, some students are doing is gonna tell me, if your numbers are signed, these are the flags. If your numbers are unsigned, these are flags. So the student give me two solutions, right? This is not the case. We have only one for each flag. We have only one of them. You get what I'm saying? So it's not like you are gonna to no. It's only one flag. Okay. So we have only one set of flags. Okay. So I'm gonna give you examples for now for sure. But at least I finished the zero flag. I finished the negative flag. Again, the negative flag, how can you use it? Also, it can be used in comparison as well. For example, if you do like A, if you do A, B take away of A, so and then after I do this operation, the negative flag is 1. What it means? If the negative flag is 1, what it means? It means the result was negative. It means B is greater than A. Okay. So what I told you guys now, number 1, there is something called the flag. These flags, every flag is a bit. Every flag is gonna update it automatically after execute every instruction. Every flag is gonna give you a different information, different data or different information. More importantly, how we use these flags. Flags are used, as I said before, for 2 things. Okay. Number 1, in case of if you want to do a comparison, or if you want to do conditions. If you want to do conditions like if A is equal to B, if A does not equal B, A greater than B, greater than or equal, less or equal, and so on. You got what I'm saying? So for this kind of condition or comparison, the flags are going to be used. Okay, as I'm going to when I explain these instructions, conditional instruction, you will understand. But I'm going to just repeat what I said right now. Okay, number 1, you need to do subtraction. After subtraction, you are going to look not you, but the instruction. Next instruction is going to look at the flag, and then it's going to decide either jump or not based on the values of the flags. Okay, so this is one use of flags. The second use of the flags to detect overflow. To detect overflow. I started last time to talk about overflow. I'm gonna finish it today. So what do you mean by overflow? I think I explained it before. It's very simple. So for overflow, if you want to add, for example, as an example, if I want to add byte plus byte, and then I want to store the result in a byte. If I want to add byte plus byte, and then I want to store the result in a byte. Okay. So overflow means you exceed the limit. That means there should be a limit. That's true. There should be a limit. Okay. What limit? I already explained the limit before. So what kind of limits do you have? I'm going to tell you. For example, this is a byte. This byte can store from 0 until 255, okay, which is 2 to the power n minus 1. N here in this case is 8. So this is the range if your number is unsigned. So if your number is unsigned, I cannot store more than 255. Is that okay? Same thing for signed numbers. There is also some limit starting from negative 128 until positive 127. Okay, this is the limit. Okay, guys. So let me ask you a question. If I add two numbers, can it happen? May it happen that the result is greater than 255? The answer for sure yes, because you add means number can get bigger. You got what I'm saying? Yeah, it may happen. If this happens, if something like that, for example, if I add here, as I said before, 255, which is 8 ones, okay, you add it to number 1. So what you are going to get here, you are going to get 0. I'm going to elaborate why, but anyway, so you're going to get 0. So because of this overflow, because the correct result is 256, and I can't store 256 in a byte. Very simple. Is that okay? That's why. So if there is overflow 100%, the result is incorrect. What you are going to get is incorrect for sure. You get what I'm saying? So, so let me ask you another question. Look here, guys. So you told me if you add two numbers, there is a possibility that these two numbers overflow can happen. However, if the two numbers have, if you do like subtraction, or if the two numbers have a different sign, so the problem happens when, for example, one number is positive, the other number is positive, or number is negative and the other one is negative. Because, but if the two numbers have different sign, can overflow happen? No, overflow cannot happen. Why? Because you are going to get the number smaller. because you subtract it, okay? So I have number in a byte, and then I'm gonna subtract from this number. So I'm gonna get a smaller number, you know what I'm saying? The problem happens when they have the two, the same sign. Both of them are positive so that the number can get bigger, or both of them are negative so that the number can get bigger, okay? So anyway, as you will see now. So, okay, now I need, so two things here you should know, guys, okay? Number one, two things. Number one, coding. When you write your code and you want to know if there is overflow or not, very simple. If your number is unsigned, look at the carry flag. That's it. So the carry flag can tell me if there is unsigned overflow or not. Is that okay? If your numbers are signed, so you have to look at the V flag. The V flag can tell you. Is that okay? This is one thing. Also, you will see tomorrow. So I shouldn't tell you, but tomorrow there is a certain code, addition, very simple code, add. Is that okay? And there should be no overflow, because every time you add, the number is still less than the limit. Okay, so it should be okay. And also, I told you to run the program twice. One time without an instruction, the other time with another instruction. In the other instruction, overflow is going to happen, and you will see it. But so two cases: one with overflow and the other one without overflow. Is that okay? You will see it tomorrow. So the other thing I want you to know, because that's what I'm going to test you tomorrow, is if I give you a question like this one, how can you calculate the value of C and the value of V? How can you calculate it by yourself, right? For sure, when you write your program, the hardware will do it for you, for sure, but you should learn how you calculate it. Is that okay? I'm going to tell you how. Look here, guys. As I said last time, there are two ways: a difficult way and easy way. Okay, let's see. Let's start, for example, with C. Okay, carry flag. What is the easy way? Okay, the easy way, you will do normal addition. For example, if I have something like that, 1 plus 1 is 0, and then we have 1 here. 1 plus 1 is 0, and then we have 1 here. 1 plus 1 is 0, and all the way until here. 1 plus 1, 0, and then we have carry. Okay, so if there is a carry resulted from the end, so whatever you are going to get here from the end here, okay, this will be stored in the carry flag. So if there is a carry here after your addition, if there is a 1, so the carry flag is 1. If nothing, if there is a 0, so the carry flag is 0. Okay, you understand what I'm saying? Also, guys, again, here I'm explaining on a byte. What if it is a word or 32 bits? It's the same thing. But for example, if it is 16 bits, so you have to see the bit. It's not going to be the bit number 7. No, it's going to be the bit number 15 if there is 1 coming from here, and so on. Is that okay? So again, so if I give you a question like this one, all what you have to do, guys, for the carry, and I'm going to choose several examples. For the carry, all what you have to do is, if you do normal addition, and then you can see if there is a carry or not. If there is a carry resulted, so I am going to put in the carry is 1. If there is no carry, it's going to put 0. Is that okay? Also, you should know if there is a carry, that means the answer is incorrect. And this is exactly the case here. So the case here, as you see here, because there was a carry here, there is a carry resulted here. So the answer is not correct. And that's true. So if you see here, I added 255 plus 1 and I got 0. The answer is not correct. Is that okay? Let's see another case without carry. This one, for example. So again, all what I'm going to do normal addition. 0 plus 1 is 1. 1 plus 0 is 1. 0 plus 1 is 1. 1 plus 1, normal addition. Okay, and then 0 plus 1 is 1. 1 plus 0 is 1. Is there a carry? No, there is no carry. Is that okay? So in this case, the carry flag should be equal to 0. Okay, and if your numbers are unsigned, so the result should be correct. And that's exactly what I did. So I converted this number to, I thought it's 170. I converted this number, I thought it's 85. I converted this number, I found it's 255. So the result is correct. Okay, guys. So let me tell you the conclusion. If you want to know if there is overflow not, there is a difficult way. The difficult way is try to, but you don't need to do it. But I'm surprised because every semester I found some students do it. But anyway, so convert it, see if the result is correct or not. So if I calculate this one, okay, then this one is 170, 85 to 55. Okay, so yeah, it is correct. So the carry flag should be 0 because there is no because there is no overflow. Is that okay? This is the difficult way. The easy way, just to do normal addition, binary addition, and then whatever you get here, if you get 0, so the carry flag should be 0. If you get 1, the carry flag should be 1. Is that okay, guys? Okay. The last one I'm going to explain now is the V flag. Okay, I told you the V flag is similar to the carry, but the V flag is going to be used for the V flag is used if your numbers are signed. It's going to tell you if the result is correct or not in case of signed. Okay, so again, how I can calculate the V flag? How you can calculate it? Okay, I'm going to tell you how. For the V flag, I'm going to tell you a very simple way to do it. Again, you can use the same difficult way I explained to you. But again, I don't recommend it. But anyway, so you can use the same difficult way. For example, here, this number should be negative 86. This number is positive 85, and this number is negative 1. So the answer is correct. So the V flag should be 0. Okay. Again, I do recommend to do this way because you are going to spend much time to do the conversion, and there is an easier approach. Okay. So what is the easier approach? The easier approach, look here, guys. I'm going to tell you a very simple way. Okay. Look here. If you add a positive number to a positive number, if you get a negative number, so that means V flag should be 1. This is one case. The other case is I'm going to add negative number to a negative number, and then I'm going to get positive number. Also, V flag should be 1. So the V flag is going to be 1 in only in one of these two cases. Only in one of these two cases. I add positive number to positive, and I get negative. I add negative to negative, I get positive. Right? Can you add positive, and you get positive? No, you get negative because it's wrong, because it's incorrect. Got what I'm saying? So, for example, so this is a simple rule you can use. For example, here, guys, look, any other case, so there is no overflow. For example, let's look at this example here. So this number is negative, this number is positive. Okay. You don't need even to think about it because the sign is different. There is no overflow. It's done. So V is equal to 0. Again, V equal to 1 just in one of two cases. You add positive with positive and you got negative. You add negative to negative and got positive. Okay. So if the sign is different, look here, I look at the most significant bit. If the sign is different, one of them is 1, one of them is 0. So for sure there is no overflow. And even this makes sense, right? Because if the number is going to get smaller, look what I'm saying. So let's see another cases. For example, here, yeah, look here, guys. So here, this one is 0 and 0, and then I got 1. What it means? It means I added a positive number to a positive number, I got a negative number. You got what I'm saying? The other case, look here, I added negative number to negative number, I got a positive number. Okay, please don't be confused. The carry resulted from here is not a part of the answer. So you answer what I'm saying. So here, after you do addition, if there is something resulted here, this is not the answer is here. I'm gonna add 8 bits to 8 bits. I'm gonna get 8 bits. The 9th bits here, this is not a part of the answer. Okay, so this is not the result I will get because I'm gonna add byte to byte. I'm gonna store the result in a byte. Okay, so so this is okay. So let me go through these slides. I'm gonna give you more examples just to understand what I said better. So let me tell you the conclusion just in few sentences. Conclusion is number 1. Carry flag can be used to know if there is unsigned overflow or not. V flag can be used to know if there is signed overflow or not. The carry flag, how can you calculate the carry flag? Just to do normal addition. 1 plus 1 is 0, and if there is a carry generated from the most significant bit, okay, so the carry flag is 1. If nothing, you get nothing, so the carry flag is 0, right? For the V flag, it's always 0, except two cases, one of two cases. When you add a positive number to positive number, you get a negative number, or negative number to negative number, you get a positive. That's it. You got what I'm saying? Anything else should be There is another case, maybe here someone can ask me, okay, you talk about addition. Okay, until now I just talk about addition. You add number to number, you add number to number. So okay, but you didn't talk about subtraction. If I do subtraction, how it would be different? Okay, let's talk about this one. If you do subtraction, how it would be different? Okay, so here, in case of signed number, actually, okay, so if you do subtraction, okay, instead of addition, you do subtraction. In case of signed number, there is no difference. What do you mean? I'm going to tell you what I mean. So if you have a positive number, and then, so what I'm going to do right now, guys, here in case of signed number, I'm going to convert the subtraction to addition, as you will see. So again, all what I explained right now, addition, right? So if you add number plus number. So now I'm asking, what if there is subtraction? So for signed number, all what I'm going to do, I'm going to convert the subtraction to addition. I'm going to use what I have just explained right now. What do you mean? I'm going to explain what I mean. For example, so if you subtract, for example, a negative number, if you subtract a negative number from a positive number, is that okay? So I'm not going to say this way. I'm going to say this is actually, I'm going to add positive number to a positive number. Okay, because when you subtract a negative number, it's similar to addition to a positive number. You understand what I'm saying? So if you subtract a negative number from a positive number, so I'm going to convert the subtraction here logically. I'm going to convert it to addition, and then I'm going to use the rule I have just explained right now. If you add positive to positive, so actually, so when you subtract a negative number from a positive number, that means you added positive to positive. You know what I'm saying? So if you add positive, so this one means it's similar to you added positive to positive. So if you get the result is positive, okay, so there is no overflow. But if the result is negative, that means there is overflow. Okay, let's see, for example, another case. If you, for example, here, same thing, for example, if this negative number and I subtract a positive number, okay? So that means here you actually added, so you actually added negative plus negative. Is that okay? So added negative to negative. Okay. Now, what if the sign is different? If the sign is different, we don't have any overflow, as I explained to you before. For example, you have a positive number and then you are going to subtract a positive number. So this one is similar to I'm going to add positive number to a negative number. Is that okay? So it's similar to adding a positive number to a negative number, and in this case, I don't need even to think about it. In this case, there is no overflow. If the sign is different, so there is no overflow. Overflow only happen when they have the same sign, so that the number can get bigger. You get what I'm saying? Actually, that's what we did. I told you, how can you get a negative number? You calculate the two's complement and you make it addition. That's what I explained, right? So what I explained is that is why the two's complement is very attractive, because you can use the addition to do subtraction, right? So actually subtraction is addition to the two's complement of the number, right? Anyway, okay. This is in case. So in case of signed numbers, there is no difference between what I explained and all what you have to do. Just you need to see, you need to convert the subtraction to addition, but you need to change the sign of this one for sure. If this one is positive, should be negative. Is that okay? Now let's see unsigned numbers, because the case is different now in the case of unsigned numbers. In case of unsigned numbers, if you do, I already explained about addition. If you do addition, is that okay? But the question now, if I do subtraction for unsigned number, if I do subtraction, is that okay? Listen to me. For example, this is number A and this is number B. If A is greater than B, if A is greater than B, okay, I don't have any problem. So you are going to get here A, take A minus B, okay? So this should be okay. There is no problem here. Is that okay? And there should be no overflow, because the sign there should be no overflow, because actually you are going to get a smaller number, right? Because you subtract. Again, overflow happens when the two numbers have the same sign and they can help each other. You got what I'm saying? So in case of subtraction, in this case, if A is greater than B, I don't have, there is no overflow because the number is going to get smaller, right? Okay, so now the other case. The other case, if B is greater than A. If B is greater than A. Someone can say, okay, so if B is greater than A, so in this case, I'm going to get a negative number, right? Because you subtract B from A, and B is bigger than A. But wait a second. Okay, logically, it's true. I should get a negative number. But keep in mind, this number is unsigned. Okay, so this number is unsigned. It cannot be negative, right? That's why in this case, we call it, and that's what I'm going to explain. So again, what I'm saying, if B is greater than A, in this case, the carry should be 1, okay? But the carry should be 1 to tell you the answer is not correct. So the answer is not correct. But in this case, we don't call the carry. The carry, we are gonna call it a borrow flag. A borrow flag. You know, when you borrow in subtraction, when you borrow, that's exactly what you are gonna get. So the answer you are gonna get here, is after you borrow. You get what I'm saying? So if you borrow a value and do subtraction, that's what you are gonna get here. So what I want to say is the following. Listen to me. In case of subtraction, is that okay? The carry flag, we call it the borrow flag. If you want to know if there is a borrow or not, okay? So in this case, the carry flag should be, the carry flag is going to act as a borrow flag. Is that okay? But there is a trick here. The trick is, we don't have two flags, one for carry and one for borrow. No, we don't do that. Okay, maybe some processor. I'm not aware of any processor doing it, but anyway, but it's the same flag, the carry flag. But in subtraction, I'm gonna call it borrow flag to tell me if there is a borrow or not. Is that okay? But there is an issue here. Listen to me. What is the issue? The issue is, again, when you do this subtraction, okay, you will find that when you do subtraction, if there is a borrow, you will find the carry flag is 0. If you do it manually by your hand, you will find after you do subtraction, the carry flag is 0. If the carry flag is 0, that means there is a borrow. That is why what's gonna happen? The carry flag is gonna be C prime. So okay, so it's gonna be C prime. So automatically the hardware is gonna flip the carry you will get in case of subtraction. You get what I'm saying? It's a little bit confusing, but I'm gonna say it again. If you do addition, the carry you are gonna get, that's what I'm gonna store in the carry flag. That's okay. But when you do subtraction, okay, what's gonna happen? The carry I'm gonna get, because again, subtraction means addition, as we said before. Anyway, so the carry you are gonna get, okay, is where we have to flip it, to convert it from carry to borrow flag, because in case of in subtraction, I'm interested to know if there is a borrow or not. You got what I'm saying? Anyway, I will go through the slides, see if I missed something. I will clarify more things here before I take any questions, maybe more examples. So anyway, let's go through the slides here, okay? Okay, so that's what I'm explaining here. Look here, guys. If you have two numbers, a plus or minus b, okay? So here, in case of unsigned here, and this is case of signed, okay? In case of signed, in case of unsigned first, if you do addition, that means the carry, if the carry is equal to 1, that means there is overflow. That means the result is too big to fit. I got a bigger result. Okay, that's what I explained. However, in case of subtraction, we are interested in something called borrow flag. I want to see if there is a borrow or not. Okay, so and in this case, if there is a borrow, actually, if you do the calculation, you will find the carry flag actually is 0, right? So in this case, we need to flip the carry flag in order to know if there is a borrow or not. Okay, I think it's done automatically by the hardware anyway. So the hardware, after I'm saying, if you do the calculation by hand, you will find if there is a borrow, the carry is 0. right? So they are opposite of each other. If you do subtraction, carry is 0, it means the borrow should be 1. If there is borrow, if there is borrow, carry is 0. If there is no borrow, the carry is 1. That's why I told you the borrow should be complement of the carry. Okay, and I think the hardware is going to do something. It's going to do this automatically in case of doing subtraction. Anyway, but if your numbers are signed, okay, here, so here overflow is going to be 1 if the result is too big, and we have only one rule here. In both cases, addition or subtraction is one rule. If you have subtraction, you need to convert subtraction to addition, and then you try to see. I'm going to add positive to positive. I'm going to get negative, or I'm going to add negative to negative. I get positive. So in this case, in these two cases, there is overflow. Okay, guys. So here what I'm saying. Let's read what I'm saying here. C is set upon an unsigned addition if the answer is wrong. So if the carry flag, if the answer is wrong. However, in case of subtraction, if you do subtraction and the carry flag is 0, that means the answer, it means the answer is wrong. Okay, because in case of subtraction, the carry flag, you have to flip the carry flag. If you do it by hand, you have to flip the carry flag to become a borrow flag, right? So anyway, in case of signed overflow, it's always if it is 1, the answer is wrong. I already explained this one, guys. If you add numbers with opposite sign, if the number have opposite sign, for sure there is no any kind of overflow, because usually overflow, the risk of having overflow happens when the two numbers are going to assist each other. It's going to get bigger, right? So anyway, that's why if they have different sign, there should be no overflow. Okay, let's see here. I think nothing. Yeah, here the carry flag should act as a borrow flag. So if the result here is less than 0, so there should be a borrow flag. Okay. So here the carry should equal not borrow. Yeah, that's what I said. Don't be confused. The carry flag or borrow flag physically, it's only one bit, right? But just in subtraction, we call it borrow. So if you do subtraction, I'm interested to know if there is a borrow or not. Okay. Anyway, so here I want you to understand better what do you mean by overflow. That's why I have this circle. This circle is very interesting. I'm assuming now I have a five-bit numbers. So as you see here, guys, the 5-bit numbers we have from 0, 0, 0, 0 until 1, 1, 1, 1, which is equal to 31. Okay, guys, see what's gonna happen if I want to add 28 plus 6. So 28 is here. 28 is here. Let's add 6 to 28. So if you add 6, so I'm gonna add 1, 2, 3, 4. If you cross this limit, if you cross here, overflow happens. You got what I'm saying? Overflow happens when you cross the limit. So now I already crossed it. So now, so 0, so 1, 1, 2, 3, 4, and then 5, 6. That's what I'm gonna get 2. You understand what I'm saying? So every time, so if I do addition, I start from here and I end here. Yeah, there is no overflow. You are okay. If I start here and then you add 3 or 4 and you end here, you are okay. Every time you cross this boundary from here to here, actually you are gonna get error, because after 1, 1, 1, 1, I'm gonna get 0, 0, 0, 0, because you exceeded the limit. Okay, guys, is that clear? I think this is very clear. Any questions? That's why if I add 28 plus 6, I'm gonna get 2. And for sure, don't be confused. I want to add 5-bit to 5-bit, and I want to get 5-bit. So this bit is not a part of the answer. It's a carry. Okay. Yes, this bit was a part of the answer. This is true if you add numbers. Keep in mind, I'm not adding numbers. I'm adding byte to byte, or 5-bit to 5-bit. I want to store the result in 5-bit. Okay. So in digital system class, right? If I give you this number, you add to this number, you would give me this answer. Is that okay? Because you add number to number. Okay. But here I'm adding 5-bit to 5-bit, so I'm gonna get 5-bit. I'm not. This one is gonna go to the carry. Okay. So anyway, so if you do addition, you are gonna get a carry here. The last one is a part of the carry. Okay. Same thing for subtraction. If you do subtraction, let's also see this example. I want to subtract 5 from 3. I want to subtract 5 from 3. So I'm going to start from here at 3, and then I'm going to subtract. So every time you add, you go this way. Every time subtract, you go this way. Okay. So if you subtract 3, you have to subtract 5. So 1, 2, 3, 4. So now you cross. So every time you cross this boundary, you actually is going to make overflow. Is that okay? So in this case, as you see here, guys, that's what, look here, very good example. Look here, you'll understand what I'm saying. Look, now, when you do subtraction, you will do subtraction here. You are gonna get this result. And if you do it by hand, you will find the carry flag is actually 0. If you do this calculation by yourself, okay, you will find the carry, if you add bit by bit, you will find the carry flag is 0. And in case of subtraction, if the carry flag, if the carry flag is 0, that means borrow flag should be 1. Okay, so the borrow flag should be the opposite of this one. Okay. Let me, for example, okay, let me do it because maybe some of you still confused. Okay, so here, this number is positive 5, right? So I'm gonna get negative 5 out of it. So negative 5 is 1, 1, 0, 1, 0, and then I'm gonna add 1. Is that okay? So actually what I did right now, I'm gonna add 1, 1, 0, 0, 0. I'm gonna add this one to this one. Okay, so I'm gonna do binary addition. So look what's gonna happen. 1 plus 1, 0, and then we have 1. 3 ones, we have 1, and there is 1 here. So I'm gonna get another 1 here. And then 0 plus 1 is 1. 0 plus 1 is 1, and there is no carry. You get what I'm saying? The carry is 0. If the carry is 0, that means that in case of subtraction, if the carry is 0, that means the result is not correct, and borrow should be 1. Is that okay, guys? Same thing. If I do subtraction and I find the carry is 1, that means borrow is equal to 0. That means the result is correct. So if the carry is 1, in case of subtraction, okay. Hopefully you are not confused. I'm gonna focus only on addition anyway in the exam, but I just want you to understand that we have something we call borrow flag. If you borrow, okay, this borrow flag should tell you if there is a borrow or not, and this borrow flag should be complement of the carry. Okay. This is actually what I have just explained right now. So look here, guys. I told you when signed overflow should happen in case of addition, and this one in case of subtraction, and you will find both of them are the same. Because I'm going to convert, this is in case of sign, because I'm going to convert the subtraction to addition. You will see right now, look what I'm going to do. If you add 2 positive numbers and I get a non-positive number, which is a negative number. So this is one case. In this case, there is signed overflow. There is another case, if you add 2 negative numbers and then you get a positive number of 0, positive or 0 number. Is that okay? So these are the 2 cases. Okay, guys? Positive or 0, okay? So I'm gonna make it very easy. Look here, guys. So look at this bit. If these 2 bits, okay, look here. Number 1, if these 2 bits are different, if the most significant bit are different, I'm talking about addition. If you do addition, if these 2 bits are different, okay, there is no overflow. The V flag should be 0. Okay, because they have the sign is different. However, if they are the same, so now, so for example, 0, 0. If they are the same, and the result I'm gonna get is different, for example, 0, 0, I got 1, or 1, 1, I got 0. Okay, that means there is overflow. Negative plus negative is positive, or positive plus positive is negative. Is that okay? This is in case of addition. Subtraction is exactly the same thing, but I'm going to convert subtraction to addition, as you will see right now. Look at the 2 rules here for subtraction, and you will see these 2 rules here are just identical to these 2 rules after you convert the subtraction to addition. Look here. If I want to subtract a positive number from a negative number, what it means? It means I'm going to add negative to negative. When you subtract a positive from negative, that means you add negative to negative. So this rule is exactly like this rule. Okay. So if you subtract a positive number from a negative, and then you get a positive result, this is exactly like this rule. Okay. Same thing here, guys, for subtraction here. If you subtract a negative number from a positive number, so positive, and then you subtract negative, that means you add positive. So positive, you add positive, which is the first case here. So, and then you are going to get a negative result. Okay, guys? Okay. Just same thing as I explained to you before, but here, I just also, I want you to better understand overflow here, okay? For overflow here, actually, we have two boundaries instead of one boundary. So here we have only one boundary. The boundary is here. Every time you create this boundary, you are gonna cause overflow. Is that okay? Here we have two, not only one. So we have a boundary here, and we have a boundary here if you are jumping from positive to negative. Because what happens is that if you are here, if you are 15 and you add 1, it's going to become minus 15, which is wrong for sure. If you add 1 more, you become negative 15. So every time you cross this is the limit for positive numbers. Okay, and this is the limit. So all these numbers are negative and all these numbers are positive. So every time you cross this border and this boundary or this boundary, you are going to cause overflow. Is that okay? So let's see the example here. Look here, guys. I'm going to add a positive number to a positive number. I get a negative number. It's for sure. So V should equal to 1, and there is overflow. Okay, logically, what happened here logically? What happened is that I start from here from 12, and I want to add 5. So if you want to add 5, so 1, 2, 3, and then you cross the border for a positive number. And now that is why when you add two positive numbers, you are going to get a negative number. Why you got negative number? Because you cross positive plus positive, and then you cross this border. Okay, so you exceeded the limit, because this is the limit for positive numbers. You exceeded the limit for positive number. This is the limit for negative numbers. So if you exceed this limit, so you are gonna. That's why if you add two negative numbers, the result is going to be positive because you are going to cross the limit here. Any questions? Let's see the other case here. The other case is, so here I'm going to add negative number to negative number. So this one is 1 and this one is none. And then the result is 0. Sorry, the result is positive, as you see here. So you added negative plus negative, and you got positive result. So overflow happens because what happened, you started from here, guys, and because you actually so here I added. So here every time you add a negative number, you move this way. So if it -1, I'm gonna move. If -2, -3, so it's moving this way. So I started from here, okay, which is -13. So every time here I'm gonna move, so I'm gonna cross the limit here. Okay. Any questions? That's what I've just explained right now, guys. I told you hardware doesn't know. So let me see what I'm writing here. So if I give you number this one, I'm gonna ask you, are these numbers signed or unsigned? The answer, I don't know. The CPU does not know the answer, right? And this is something left to the software. The software has to interpret the flags. Which flag you have to look at? Look what I'm saying. Any questions? Okay. So what I'm gonna do, because that's what I'm gonna ask tomorrow in the quiz. So I don't want to spend, so I'm gonna just go through this because that's what's gonna be in the quiz. So let's try to this one up by ourselves, guys. Okay. So let me just hide all of this. Okay, let's do it. If I give you someone, that's what I will do tomorrow. I will give you a question like this one. So I'm gonna ask you to show me the flags. Okay, calculate the flags. That's it. Okay. So all what you have to do, number one, you have to do normal addition. I'm gonna only focus on addition. Okay. So you have to do just normal addition. 1 + 1 is 0. 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 And then there is a 1 resulted here. Okay. So let's start with the carry flag. Is there a carry flag resulted from here? There was 1 when you did the addition? Yes. So the carry flag should be 1. Is that okay? Now let's look at the 0 flag. Okay, look at the result. That's very easy. Let's look at the result. Again, the carry is not a part of the result. When I say result, I mean you add byte to byte, I'm going to get a byte. You add word to word, I'm going to get a word. Is that okay? So So here, look at this here. Okay. So is the result is 0? The answer is yes, it is 0. So that's why the 0 flag should be 1. Because the result is 0. Is that okay? Okay. Now let's look at negative flag. Is negative flag, as I told you, just you repeat this bit. This bit should come here. Okay. Because the answer is not negative. That's why you have 0 here. Okay, guys. The last thing is overflow. Is there overflow or not? Let's see what I did here. You don't even need to think about it, because this is a negative number and this is a positive number, right? You add negative to positive, so they have different sign. So there is no overflow. Okay, guys. That's what I will do tomorrow. I will give you something like that. I'm going to ask you to calculate the flex. Is that okay? Now let's interpret the flex. Interpret what I did right now. Let's interpret it. So look here, guys. Because the carry flag is 1, that means if your number unsigned, we have overflow and the result is not correct. It's not correct. And that's exactly what I did. So here, yes, I did the calculation. I find this true. Also, because V is equal to 0, that means if your numbers are signed, so the result is correct. And that's exactly what I did. -1 plus 1, I got 0, which is correct. Any questions? I'm gonna go through. Maybe I'm gonna do two more examples, but I will try to be fast. Okay. Any questions? If you have any questions, just raise your hand. Okay. Let's see another one here, guys. Again, I want to hide these ones. Okay. And then, yeah. Again, you are adding 2 numbers. Okay. So just you add bits, binary addition. 0 plus 1 is 1. Okay. 1 plus 0 is 1, 0 plus 1 and 1, and so on. So that's what I did here. Is there, when you did addition, 1 plus 1 is 0. Is there a carry? No, there is no carry. Okay, the carry flag should be 0. That okay? Easy. Now, this is the result. Is the result negative? Is the result negative? Yes, the answer is yes. So this bit, actually, I can make it easy. Just this bit has to come. Is the result 0? No, the result is not 0. That's why the 0 flag should be 0. To tell you no. 0 means no, it's not 0. You got what I'm saying? Okay, now let's see the overflow flag. I don't even need to think about it, because they have, I'm gonna add 2 different signs. So for sure there is no V overflow. You don't need to think about it. Okay. Now let's interpret what I did. So here, look here, guys. That means if your number are signed or unsigned or signed, in the 2 cases, in both cases, the result is correct, because there is no overflow in the 2 cases. That's true. So if I convert the numbers to decimal, you will see in the 2 cases I got correct result. Okay. I want to tell you something also, maybe me confused a little bit. There is no relation between signed or unsigned overflows. So say it again. I mean, if there is signed overflow, it doesn't mean it should be unsigned overflow, or the other way. There is no relation. That's why I intentionally here in this example, I give you 4 examples. Look here. This one has unsigned, but it doesn't have signed. This one, it doesn't have both. Another example, it has signed, but it doesn't have unsigned. Another example, it has both. So there is no relation. Why there is no relation? Because every one of them has different limits. The limit is different in both subjects. Okay? Anyway, so let's have these 2 examples, and this should be more than enough. Okay, hopefully you do well tomorrow when I give you this question. Okay. Also, there will be some question. So tomorrow's quiz is going to cover chapter 1. There will be some question about conversions, how convert hexadecimal to binary, binary to hexadecimal. Also, maybe I'm gonna give you. I'm gonna tell you. Give me the. If I tell you, convert to +5 and store it in a byte. Okay, so I can do this way. Look here, guys. +5 in a byte. So 1 0 1 0, and then 0 0 0 0. Is that okay? This is a +5. Is that okay? If I tell you I want to store +5 in 16 bits in half word, right? Okay. So it's how it can be. So it's going to be 1 0 1 0 0 0 0 0, and then 0 0 0 0 0 0 0 0. Is that okay? 16 bit. Is that okay? So I can store 5 in a byte. It can be in a word. If it can fit a byte, if it can fit a byte, it can fit 16 bits. Anyway, okay, guys. So number 2, if I tell you, give me -5 in a byte, also give me a -5 in 16 bits. Again, the easy way, there are different ways, but the easy way, as I told you before, just to get, in order to calculate -5, just to get +5 and calculate the 2's complement. Is that okay? So if I take this one and I calculate the 2's complement of this one, so I'm going to get -5 in a byte. Okay? So let's see. So in a byte, it's going to be like 0. As I said, the 2's complement is the 1's complement plus 1. So it's going to be 0, 1, 0, 1, 1, 1, 1, 1. Is that okay? And then I'm going to add 1. So it's going to be 1, 1, 0, 1, 1, 1, 1, 1. Okay, so this one is actually -5. Okay. So okay, if it is in a word 16 bits, it's the same thing, 16 bits. Okay, but just you have more zeros here. So let's do it. So it's going to be the same idea. So it should be 0, 1, 0, 1, 1, 1, 1, 1, 1, 1, 1, 1. Okay, and then you add 1. So it's going to be 1, 0, 1. Sorry, going to be 1, 1, 0, 1, 4 ones, 4 ones. Okay, guys. So this is also -5. Okay. I'm going to tell you something right now. I'm going to explain it later, but it just happened right now. I want to focus with me. Okay. So this is +5, but it's stored in a byte. This is +5, but it's stored in 16 bits. Okay. Look at these 2 numbers. All what I did, I just put zeros on the left. Is that right? So all what I did, this is +5, and then I put zeros here, as you see here. Okay, that's what I'm going to teach you later. We call it extension. So what do you mean by extension? I mean, if I store a number in a byte and then I want to extend it, so I want to store the same number but in a bigger space, the same number. Okay, so in this case, I just added zeros to get the same number. Okay, zeros on the left. Okay, however, if the number is negative, you are going to add ones to keep the same number. Okay, so that's exactly what I did here. Look at this one and this one. So this one was -5. If I want to get, because usually we say if you put zeros at the left, it's not going to make change to the number. That is true, but this is true for unsigned number and positive numbers. For negative number, to get the same number, you have to put ones. Ones are not going to change the numbers. You get what I'm saying? Anyway, I'm going to explain it later anyway, but try, that's what we call extension. So I want to get the same number, but in bigger space. So what I'm saying, if the number is unsigned, you just put zeros. If your number is signed but positive, you just put zeros. However, if your number is negative and I want to get the same number, you put ones. As you see, ones is not going to change the numbers. Anyway, okay, guys. So the last, I'm going to go through just these 2 examples. Okay, let's see these examples again. I want to hide these ones. Okay, now I'm going to do addition. Again, this is just normal binary addition. 1 plus 1 is 0, and then I'm going to have here 1. 1 plus 1 is 0, and then we have 1. 1 plus 1 is 0. We have 1 until 1 plus 1 is 0, and then we have 1 here. Okay, so this is the result I got. So let's start one by one. Is there a carry resulted here? No, there is no carry. Nothing was the result. That's why I'm going to put 0 in the carry flag. Is that okay? Okay. This is number 1. Number 2, let's look at the result. Is the result 0? This result, is it 0? No, it is not 0. That's why the 0 flag should be 0. To tell you it's not 0. Is that okay? Now, let's look at, is the result negative? Yes, it is negative. Or is it just this bit is going to come here, as I said? Yes. Okay. Now, let's look at the overflow flag, V flag. Look here, guys. This is a positive number. This is a positive number, and I got a negative number. Positive plus positive, I got negative. That's why V should be equal to 1. Okay. Let's interpret it here. So now these results are telling me a few numbers are unsigned. Okay, so there is no overflow. But if it is signed, there is overflow. Okay, so that means this is a correct result. If your number unsigned, you got a correct result. But if your numbers are signed, you get wrong results. And this exactly, I did the conversion. That's what happened. Okay. Because 127 plus 1, I was supposed to get 128. However, my limit is positive 127. That's my limit. So I exceeded the limit. Okay. Any questions? Okay. Let's do the last example quickly. So if you see here, guys, again, I'm going to just do normal addition. I found that a carry resulted from here. So that's why the carry is 1. Also, this is the result. Don't look at the carry again. It's not a part of the result. This is the result. Okay. This number is positive, so this bit has to come here. Okay, because this is not negative. Also, because the result is not 0, so the 0 flag should be 0. Now let's look at the overflow. This is a negative number. I added a negative number to a negative number, and I got a positive number. So that means there is overflow, right? That's why V should be 1. Again, let's interpret it. If you do the conversion, so the result here is telling me, in this case, if your number signed or unsigned, there is overflow. And that's exactly what happened. When I translated it, when I converted to decimal, I added 172 plus 138, and I got 52. Also here, I added negative 84 plus negative 115, and I got 54. So, any questions? Okay, great. So I think that's enough for this chapter. Okay. We still have 8 minutes. 8 minutes. You should learn when you come to my lecture, we're gonna take all the time. Okay. Yes. So sorry, before I forget. So the recording I made right now, I will try to post it after this lecture, so that if you want to study for tomorrow's quiz. Yes.
So for the lab tomorrow, is there anything we need to bring down?
Yes. So for the lab tomorrow, I posted the lab description. In the lab, as I said before, you are going to work in group of 2. We need from each group, you need only one laptop should be enough. And then you have to download a program. You need to read. You need to try to read the lab before you come. Download the program. Okay, so that if you have any trouble getting it working, you can we can help you tomorrow. Is that okay? The program we have is for Windows. This program is for Windows. So if you have a Windows computer, you should not have a problem. But if your computer is Mac, what we did before, you have one of 2 options. Either you can have dual operating system, okay, one for Windows and one for Mac. The other option, there is something called virtual Windows. But there are some programs you can download. It's called virtual Windows. Is that okay? So try to download the program. Okay, make sure it's working. Okay. Okay. Any other questions? Yes. That's okay. There is a table. You have to fill up this table. If you want to print it, that's okay. If you want to take it in a note, and because tomorrow you are not going to submit anything, okay? So we're going to explain tomorrow what you have to do, but usually what we do in every lab, we help you during the lab. Once you get it done, you need to submit the report in next lab. So in every lab, you have to submit the report in the next lab. Is that okay? So this, I give you very specific question you have related to the lab. You have to answer it in the report, okay? And by the way, anyway, I will say tomorrow, but that's okay. We need only one report from each group. Look what I'm saying. So it's not one report per students, per group, and every group has 2 students, right? And we assume the 2 students working equally on the lab, 50%, 50%. So you work together. Okay, it's not like we make a group and one is going to do all the work, the other one is going to just watch. Okay, what's going on? So we are not expecting that. Okay, we are asking only for one report, and usually the two person gets the same grade. Okay, if we feel that both of them worked on the lab. Anyway, so we still have 5 minutes. So chapter 2, in chapter 2, guys, I'm going to talk about assembly language. I'm going to give you more. Yes.
Project file, zip file, the link doesn't work.
Yeah, that's why I sent. Are you in the mailing list? My mailing list? Okay, this is a good thing. For some reason, I put a link for a template project you have to use. This link is working very well on my Word file, but when I converted the Word file to PDF, it doesn't work. Okay, that's why I sent you the template and email. I sent you email with the link and also with the template itself. Okay. So now, so in this, I did not. I just in chapter 1, I told you there is something called assembly language. And that's what you will see tomorrow. I told you in assembly language, we have English words. That's what we are going to use. You are going to use English instructions. And every English instruction has to be translated to machine code. And this is the purpose of tomorrow's lab. So everything I taught in chapter 1, you will see tomorrow. You will see the memory locations. Okay. You will see the flags. You will see the registers. You will see PC. You will see the assembly instruction and the corresponding machine code. You will see everything, okay, tomorrow. So here, I'm going to teach the assembly instruction. For sure, tomorrow, I'm not expecting, tomorrow, the purpose of tomorrow is just to get familiar with the compiler, the compiler we are going to use, okay? I'm going to give you a program just to run. I give you some comments in the program to just understand the instruction, but for sure, I'm not expecting you because I'm going to start teaching assembly, okay, starting from maybe next lecture. So I'm not expecting you understand any assembly, okay? But I'll just give you some comment to understand what this instruction is doing, okay? But anyway, so here, this is, so in the first part here, guys, I'm going to talk about the structure of the assembly program. Okay, and then I'm going to talk about first here, I'm going to talk about the assembly language program structure. Okay, then I'm going to talk about instruction we use for data transfer, arithmetic and logic instruction, shift and rotate instruction, branch and loop instruction, finally stack and subroutines. Okay, so yeah, so this is the standard structure. You will see this structure for sure. For every assembly program, we are going to have a structure like this one. And that's the structure you are going to see tomorrow. So as you see here, guys, the assembly program is going to have two regions. One region for code, another region for data, any variable. So as you see here, guys, region or area, whatever you call it. So here, first, we use the word as a keyword area. Okay, I'm going to give you more details for sure. So here, area code. So here, so what you are seeing here, all your instructions have to be here. So in this area, you can see there are two parts in your code, as you see here, guys. There are two parts. One part for here's the program, here's the code, and here's the data. Okay, so your program should have, if you have data, and you have, for sure you should have code. But in some programs, you may not have data. For example, you don't have variables, you don't have arrays, whatever. But usually, if you have data and you have code, you have to do two definitions for two areas, okay? One for the code, so any instruction has to come here, and one for the data, any data definition should come here. Don't be confused. So here in this slide, I put the code first, and then I put the data. I think in tomorrow's lab, I put the data before it. It doesn't matter. You understand what I'm saying? So this part for your data and this part for your code. Okay, the order doesn't matter. So this part, I can start with this here, I put it here, or the opposite, it doesn't matter. Is that okay? So again, in the data area, I make any definition, I put it here. And tomorrow, I think there is a variable, I define this variable tomorrow. So any definition, if you want to define arrays, if you want to define variables like any any programming language, there should be here. Your code instructions have to be here. So this is how the program, how the program. Also, as you see here, we put comments. You know, for any programming language, we put comments. These comments, so here in assembly, we use semicolon. So if you see semicolon here, the semicolon means this is a comment. You know, in C language, we use double backslash or use something like that. Okay, but here in assembly, we use comment. So here I put a semicolon. So if you see semicolon, so that means it's comment. Okay, anyway. So I'm gonna continue it next time also. Okay. So again, as I said to you before, everything in this course is open book. So you can print the slides for chapter 1. You can use them. Okay. But I'm not gonna. Electronic devices are not gonna be allowed. So you cannot use the you cannot use your laptop or smartphone. Only any printed material. Okay. And as I said, the quiz should cover chapter 1.